Okay, let's start. Today I'm going to discuss paper number 6. Paper number 6, mock exam 6. Okay, do with me. I'll start from the beginning. Part A, collision correction using just conservation of momentum. You can do that one, then I'll do that one. Two particles of mass 2m and m moves on a plane with velocities 2u and u in the same directions. Okay, now question number 1, part A. Here one particle 2m, the other particle m, it moves same direction 2u and u. Then after that it get mass 2m, 3m. Then take velocity v. Then conservation of momentum. Here this direction 2m times 2u, m times u equal 3m times v. Then cancel masses, v equal 5u divided by 3. Here the velocity, v equal 5u over 3. Find energy loss due to this collision. Energy loss. Then energy loss delta E, initial energy half 2m 2u square plus half m u square. Here initial kinetic energy minus final kinetic energy half 3m, here 5u over 3 square. Now here this velocity, here kinetic energy loss. Now you can simplify this. 1 over 2 mu square take outside, 1 over 2 mu square, here 4 8, here plus 1, here 1 over 2 mu square, here 3 25 over 9. Now further you can simplify this one. Then 1 over 2 mu square, here 3 8 9 27 2 over 3. Then here 9 27 minus 25 2 over 3. Then mu square divided by 3. Here kinetic energy loss. Kinetic energy loss. Then due to this collision there will be a loss. Then first you find after collision velocities. After collision velocity, then take energy difference. That's it. That is question number 1. Question number 1. Okay. Then question number 2. Question number 2. Projectile correction. Projectile correction. A particle is projected from a point 3h above the ground. Here it is. Here 3h. Particle is projected at an angle theta to the horizontal at this velocity u. If maximum height of the particle from the initial position is h, it goes like this. Then maximum height of the particle from the initial level h. Then we need to find r. We need to find r. Then here at this position vertical velocity 0. Then here horizontal velocity u cos theta. For projectile motion at the maximum height, the vertical velocity 0. Therefore, take A, B, C. Then AB motion, use upward v square equal u square plus 2as first. Then v velocity 0, u sin theta 2gh s square. Then u square sin square theta equal 2gh. Take first relation. Okay. Then AC motion s equal ut plus half at square equation, horizontally, then r value u cos theta, here u cos theta times t, second equation. Then vertically, upward, here downward displacement minus 3h u sin theta, velocity u sin theta times t, g over 2 t squared. Here third equation, second equation, third equation. Okay. Then you can simplify that one. Then you take time here and substitute. Then minus 3h equal u sin theta, t mean r over u cos theta. No? G over 2 r over u cos theta squared. Now simplify. Minus 3h equal r tan theta, g over 2 r square over u square cos squared alpha, cos square theta 1 over. Now further simplify. Then here u square value, u square take from here, u square equal 2gh divided by sin square theta. Then put that one here, minus 3h r tan theta g r squared over 2 u squared, u square means 2gh, over sin square, that goes to upstairs. Now further simplify, cancel g. Then minus 3h equal r tan theta minus r squared over 4h tan square theta. Then now that is in quadratic format of r, no? Then multiply and take tan square theta into r squared minus 4h tan theta times r and minus 4 12h square 0. Now here the quadratic equation in terms of r. Cross multiply, here 12h squared, here r tan theta, then 4h r tan theta, then here r square tan square, take the other side. Now you can find r. Then find r value. Minus b 4h tan theta plus or minus b square 4h tan theta minus 4 a value tan square theta, c value minus 12h square root divide by 2a, here tan square theta. Okay, now by this one you can simplify the thing. Okay, do up to that. Here tan theta common, cancel one tan theta term. And here 4 common, here 4, you can simplify. Do up to that. Okay, let's first simplify. Now here r equal 4h plus or minus here 4h squared minus plus 4 into 12h square root divided by 2 tan theta. Then 4h plus or minus here take 4h outside, here 1, here 3 root over 2 tan theta. Then cancel by 2, then 2h plus or minus here 4h over tan theta. Then r value greater than 0, therefore r equal 6h divided by tan theta. Then take only positive value, then 6h cot theta, 6h cot theta. Okay, completed. That is question number 2. Okay. Then question number 3, system of Pulik action. Now here the system like this, mark forces here Q, 3G, here take tension T, here 5G, here R, here particle P. The system shown in the figure is released from rest at the instant where the particle reach B, string is cut. Find time to reach C. Okay, then first you find the velocity at B. Find time to reach B. Okay, now F equals ma. First find acceleration. Q particle downward, 3g minus t equal 3. Here take F. 3F. Here P particle horizontally, t equal 5F. Here 1 and 2. 1 plus 2, 3g equal 8F. Then F equal 3g divided by 8. F equal 3g divided by 8. That is acceleration. Now you find velocity at B. Use this say v square equal u squared plus 2as. Here when it come to B, its displacement 1 meters. Then say Vb, initial velocity 0, acceleration F no. Then 3g divided by 8, displacement 1. Then 3g divided by 4. Vb value square root 3d divided by 4. Here velocity at B. Then it goes with same velocity now. Then BC displacement 2 meters. Therefore now time to reach C. Then 2 meters divided by its velocity Vb. Uniform velocity. After cutting this string, it moves with uniform velocity. Then 4 divided by 3g root. That is it. System of Pulik action. First you find acceleration, then you find velocity, thereafter you find time to reach that point using general equation of motion. Complete. That is question number 3. Okay, then question number 4, work power energy question. Just using physics you can find it, then I'll do that. Question number 4, the total mass of cyclist and the bicycle m kilograms. When he rides his bicycle up a hill of inclination alpha to the horizontal, resistance R with velocity V. He works at power capital H. Show that H equal R plus mg sin alpha plus V times V. Okay, question number 4. Here inclination alpha, take here the cycle, weight mg, resistance R. Let this tractive force P, and better to mark reaction as L, say R dash. Okay. Now power capital H watts now. Then this time velocity V. Now upward F equals ma. Okay. Now F equals ma, P minus R minus mg sin alpha. P minus R minus mg sin alpha equal m acceleration A. You take constant velocity, then acceleration 0, then P equal R plus mg sin alpha. Then use H equal PV, then H equal P R plus mg sin alpha times V. Here velocity V. Then work power energy, we have only one equation, that is H equal PV. One equation, H equal PV. Then you can apply again equation of motion and F equals ma equation. That is question number 4. Completed. Okay. Then question number 5, circular motion question, horizontal circular motion. A particle P of mass m is suspended by a string of length L from point O, and it completes a horizontal circular motion with radius L sin alpha below L cos alpha height with constant angular velocity omega. Okay. Now here question number 5, circular motion, horizontal circular motion. Here the motion now. Angular velocity given omega, mark forces, here weight, mass m, then weight mg, then tension T, here height below L cos alpha, mean here alpha, L given, then here radius, R equal L sin alpha. For horizontal circular motion, need to only consider vertical equilibrium and towards center F equals ma. Then let's consider vertical equilibrium. T sin alpha equal mg. T sin alpha equal mg, first one. Then towards center F equal ma. Yeah, equilibrium. Then T cos, here T cos alpha, no? T cos alpha Then here t sine alpha, a mean radial acceleration, that is r omega squared. Then t sine alpha equal m, r mean L sine alpha omega squared. Now simplify, cancel sine alpha. Then here t value equal ml omega square. Here second equation, you put that one here. Then by 1, t mean ml omega square, you put it here, cos alpha equal mg, then cancel m, then cos alpha g divided by L omega squared. Then alpha cos inverse g over L omega squared. Get the equation. So definitely for your A-level question there will be horizontal circular motion part. Then for horizontal circular motion, you take general position, mark all forces, then consider vertical equilibrium and put towards center F equals ma. Okay, that is question number 5. Complete. Then question number 6. Here, vector dot product question, simple question. So you need to consider dot product. Vector A given, 2i plus 3j plus 5k. Vector B given 3i minus 4j minus 6k. Then A dot B 2i plus 3j plus 5k dot 3i minus 4j minus 6k. Okay. For dot product, you better write I dot I equal j dot j equal k dot k 1. I dot j, j dot k, I dot k, here 0. Therefore, A dot B, you multiply I and I, 6 I dot I, 1. And multiply j dot j, 3 times 4 minus 12, j dot j 1, here k dot k, 5 times 6, 30. Then A dot B equal, here minus 36. That is question number 6. Then question number 7. Equilibrium of particle question. Weight is suspended of two light extensible string of length 3m and 4m to 2 points on same horizontal line separated by 5 meters distance. Here 5 meters distance separated, two strings 3m and 4m. Then here this will be definitely 90. then particle attached. Then its weight 25 kilograms, 215 newtons. Then mark tensions T1 and T2. Then here Pythagorean triple, take this angle alpha, 90 minus alpha, alpha. Find tension in the string by using force triangle. By using force triangle, not using Lami's theorem. Okay, now sketch force triangle. Here downward 250, here T2, T2 and T1 this way. Then angle between T1 and T2 90, here alpha, here T2 to the vertical alpha, here alpha. Here it is now. Then you can find sin alpha and cos alpha. Sin alpha 4 divided by 5. Cos alpha 3 divided by 5. Cos alpha 3 divided by 5. Then apply sine rule now. Then T2 over sin 90 minus alpha. T1 over sin alpha. 250 over sin 90. over sin 90. Okay. Then T2 over cos alpha, T1 over sin alpha equal 250. Then you can easily find T1 and T2. Okay, then T1 equal 250 sin alpha, then 250 sin alpha 405, 200 Newton. Then T2 equal 250 cos alpha, then 250 cos alpha 305, 150 Newton. That is question number 7. Then question number 8, friction question. Uniform rod is placed in limiting equilibrium inside a hollow rough hemisphere of coefficient of friction mu. The rod subtend angle 90 of its center. Show that the inclination of the rod to the horizontal. Inclination of the rod need to find. Then definitely better to use Cot theorem, no? Better use Cot theorem. Let's sketch that. Question number 8. Rough hemisphere. Here hemisphere. Here the rod. Then reactions passing through the center. R1. Here R2. It subtend 90 here. Then here 45-degree inclination. 45-degree inclination, weight W, then to the horizontal angle theta. Need to find to the horizontal angle theta. Then produce this. Then it moving to shift downward. No? Then friction, opposite direction, say F1. Here friction upward, say F2. Now it is in equilibrium. It is in equilibrium. Then you better to make concurrent forces here. Better to mark it. Here concurrent. Then here take this angle lambda. Angle of friction. Here take this angle lambda again. Angle of friction lambda. Then angle of friction mean angle between reaction and the resultant. Then here reaction and the resultant. Then theta, 90 minus theta, here 90 minus theta. Then apply Cot theorem, ratio 1:1 ratio. 1 plus 1, 1 plus 1, cot 90 minus theta equal, here 1 cot, here 45 minus lambda minus 1 cot 45 plus lambda. That is Cot theorem. Cot theorem. Now just simplify this. 2 tan theta, here 1 over tan 45 minus lambda, tan 45 minus tan lambda, 1 plus tan 45 tan lambda minus yet 1 over tan 45 plus lambda, then tan 45 plus tan lambda, 1 minus tan 45 tan lambda. Then here 1 minus 1 plus tan lambda, we say tan lambda equal mu. 1 plus mu, 1 minus mu. 1 minus mu, 1 plus mu. Okay, this is it. Now you better to simplify this common denominator, 1 minus lambda, 1 plus lambda, 1 minus mu, 1 plus mu. Cross multiply 1 plus mu square minus 1 minus mu square. Now you can simplify that. Then here 4 mu, 1 minus mu square. That is 2 tan theta. Okay. Then you can find tan theta, 2 mu over 1 minus mu squared, then theta equal tan inverse 2 mu over 1 minus mu squared. That is the angle. Question number 8. Complete. Question number 9, 10, probability and statistics section, we haven't done that one. Then I'll skip that part. Question number 9 and 10. Okay. Then question number 11. Question number 11, linear motion and relative velocity question. Linear motion and relative velocity question. 11 part A. Here the track A, B, C, H. Here A divided by 3 displacement, A divided by 3 displacement, A divided by 3 displacement, retardations, here F, here 2F, and here 3F. Here initial velocity U, here end velocity 0. End velocity 0. Then successive displacement case. Successive displacement case. Now here this case, simplification is the important one. Simplification is the important one. Anyway, always VT graph, velocity time graph, then we have only two properties. One property, displacement driven by area bounded by the curve, and the acceleration given by the gradient. That's it. Okay, let's sketch this graph. Here time, velocity, initial velocity U, then retardation F, then 2F, then 3F. Take this angle alpha, take this angle beta, take this angle gamma, here acceleration F, retardation 2F, retardation 3F. Then take these times T1, T2 and T3. Then here displacement A by 3, A by 3, here A by 3. Then velocities V1 and V2. V1 and V2. Here the sketch now. Okay. Now let's write relations. Let's write relations. First area relation. Here this area, A divided by 3 given by half into T1 into U plus V1. Here first one. Here A divided by 3. Half into V1 plus V2. T2 into V1 plus V2. Second equation. Then A divided by 3. A divided by 3. So that is equal to area of this triangle half into T3 into V2. Here third equation, area relations. Then gradient relations, U minus V1, F equal U minus V1 divided by T1. U minus V1 divided by T1. Say fourth equation, then 2F equal V1 minus V2 divided by T2. Then 3F equal V2 divided by 3. Sixth equation. Okay. Now the best simplification here is multiply 1, 2, 1, 4, 2, 5 and 3, 6. Then you can cancel time, no? Then add them together. Then add them together. So here it is. 1 into 4, 2 into 5, 3 into 6. Then A over 3F. A over 3 into 2F. A over 3 into 3F. Here cancel T1, half common. Here difference of two squares, U square minus V1 square. Here again difference of two squares, V1 square minus V2 square. v2 square. Again, when you multiply these two, you get v2 squared. Okay, now simplify. v1, v2 cancel. Then here af divided by 3 common. Here 1, here 2, and here 3. Here 1 over 2 u squared. Then here 2, 5, 6. 6af divided by 3 equal 1 over 2 u square. You subject f. U square divided by 4a. U square divided by 4a. That is the best simplification. So here we have successive displacement thing. First write displacement relations, then corresponding that write gradient relations, then better to multiply and add them. Then you can cancel time, and also you can cancel velocities, unknown velocities. Then here f value. Then by 3 and 6, 3 into 6, a over 3, 3f. v2 square over 2. Then v2 equal 2af root. v2 2af root. Okay. Then multiply these two, 2 and 5, 2 and 5. a over 3 2f. One over 2 v1 square minus v2 square. Then 4af over 3 v1 square minus v2 square. Here 2af. v1 square 4af over 3 plus 2af. 10af divided by 3 root. Here v1. Now we know velocities v1 and v2. Then we can go further. Okay, do up to that. Okay, now then you need to find total time. Total time. Here time, you better to get this relation. T1 equal u minus v1 over f. T2 equal v1 minus v2 over 2f. T3 v2 over 3f. Then total time. T1 plus T2 plus T3. T1 u minus v1 over f. T2 by this v1 minus v2 over 2f. T3 v2 over 3f. Then get common denominator 6f. 6u, 6v1, 3v1, 3v2, 2v2. Now simplify. 6u, 3v1 minus v2 over 6f. Then here this relation 6u. Then separate denominator and take u outside. U divide by f. Then 1 minus 3v1 plus v2 over 6u. Okay, na? Here take f outside and u outside. Then here 6 over 6, 1. Here minus, these two get plus 3v1 plus v2 divided by 6u. We take u outside now. Here the relation now. Then we know v1 and v2. We know v1 and v2. Then substitute them and simplify. Okay, continue now. Here simplification is the most important one. No? Simplification is the most important one. U divide by f, 3v1, 10af over 3, v2, 2af, 6u. U equal 4af. Okay. U of f 1 minus here 30 plus here root 2 and here 12. Cancel AF term and AF term. Then U value equal replace f. F mean U squared of 4a. Simple question, but simplification little harder. You need to practice well. Okay, complete that. Okay. Now question number 1 part B, 11 part B. Relative velocity question. Relative velocity question. Okay, let's see that. Here given ship A observe another ship B 20 kilometers due east of A. 20 kilometers due east of A. B is steaming north at speed 24 kilometers per hour. B velocity given, that means velocity with respect to Earth given. If the ships are found to be nearest to each other at distance 12 kilometers, find the velocity of A. Okay, let's do this way. 11 part B. Ship A observe another ship B due east of A. Here B, 20 kilometers. Its velocity upward 24 kilometers per hour. Then velocity of B with respect to Earth due north 24 kilometers per hour. 24 kilometers per hour. After 20 minutes, 24 minutes, if the ships are found to be nearest to each other, then I'll sketch relative path. Here I'll sketch relative path like this. Here locus of B with respect to A. Then to get nearest path, nearest shortest distance, then you better to get resultant relative motion. Then here the relative motion. Then nearest distance 12 kilometers. Then that is the perpendicular distance. Okay. Now it takes 24 minutes. Here from here to here it moves with 24 minutes. Okay, take this angle alpha. Then sin alpha value 12 over 20. 20, that is 3/5. 3/5. Then here take this displacement S. Then displacement S equal 20 square minus 12 square root. Then 4 common, no, take it outside. 5, 3, 4. 16 kilometers. It have to move. It has to move. Okay, it has to move. Then relative to A, B need to move 16 kilometers. 16 kilometers. Then the time given 24 for this motion. 24 minutes. Then 24 divided by 60 in hours. Then you can find relative velocity now. Velocity of B with respect to A. Here displacement known, time known. Then displacement divided by time. 16 divided by 24 divided by 60. 60. Here the relative velocity. Now simplify. 12, 2, 5, 8. Then 40 kilometers per hour. Here relative velocity 40 kilometers per hour. Now we know its direction alpha. Alpha 3/5. Here angle alpha 3/5. Alpha. Now find the velocity of A. Velocity of A. Now velocity of A with respect to Earth equal velocity of A with respect to B plus velocity of B with respect to Earth. Velocity of A with respect to B. Here opposite direction 40. Here 40, upward 24. Now here 40 sin alpha, 40 cos alpha. Here 40 sin alpha, here 24. Sin alpha 3 divided by 5. 24. Then we have only due north velocity 40 cos alpha. Cos alpha 4 divided by 5. (32 kilometers per hour). due north. Here the velocity of A, 32 kilometers per hour due north. That is the velocity. That relative velocity equation, not general type 1. You have to think little, then you can go for the answer. Complete it. Okay. Now let's move to question number 12. Question number 12, relative acceleration, system of wedges question and circular motion question. Okay, let's move to that. Question number 12, part A. 12 part A. A wedge of mass 3m is free to move on smooth horizontal floor, and particle of mass m placed on surface of an inclination alpha to the horizontal and project with initial velocity u along the surface. Okay. Inclination alpha to the horizontal. Then here the wedge. Alpha. Here smooth floor. 3 mg. Here mg. Here r. r1. Then take acceleration f. Take acceleration a. Okay. Now let acceleration of 3m with respect to earth horizontally a, acceleration of m with respect to 3m f, then acceleration of m with respect to earth 3m e to the horizontal alpha f, here a. Then here relative acceleration a f vector addition, a f vector addition. Okay, you can take this. Then use f equals ma. First system horizontally, then no forces 0. Then we have two objects 3m and m. 3m into its acceleration a, m into its acceleration here a plus f cos alpha. Consider horizontal component, a plus f cos alpha, say 1. Then simple m along the surface, then mg sin alpha equal m acceleration f plus a cos alpha. F plus a cos alpha. Here second equation. Always use with respect to earth acceleration. Now simplify. So we need f. We need f. Okay. Now let's simplify. Cancel m. G sin alpha f plus a cos alpha. Then a equal g sin alpha minus f divided by a cos alpha. Then substitute for 1. Here 0. 3ma, 4ma, cancel m. Here 4a plus f cos alpha. Then substitute a here. A equal g sin alpha minus f of cos alpha. Okay. G sin alpha minus f over cos alpha. F cos alpha. 0 equal 4g sin alpha minus 4f plus f cos squared alpha. Now you can find f value. 4 minus cos squared alpha f equal 4g sin alpha. Sin එක මික්ස් එකක් තියෙනවා. එතන මයිනස් නේ. minus 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 minus. Okay. Now complete simplification. Okay, then here f equal minus 4g sin alpha. Here 4 minus cos squared alpha, 3 plus sin square alpha. 1 minus cos square alpha sin square, then you better to get that format. Here f acceleration. Show that the particle reached maximum height after time. So now you use v. Here v equal u plus at with respective to 3m. Then when it comes to rest, velocity 0, initial velocity u given. Here with respective to 3m mean its acceleration f. Its acceleration f. Then f t. Then time equal u divided by f. U divided by f. For g sin alpha, 3 plus sin squared alpha. Now u divided by 4g, separate denominator, 3 over sin alpha cosec, 3 cosec alpha, sin over sin 1, sin alpha, sin squared over sin. Then separate denominator, then you can get the answer. That is part A question. Complete. Now then question number 12 part B, circular motion question. Circular motion question, particle of mass m hung by light inextensible string of length a from fixed point O. The string is initially vertical and the particle given horizontal velocity nh root. Okay. Now just vertical circular motion question type. Then first we need to prove inequality, that is general proof. So let's do that. Thereafter, when the string OA reaches the horizontal, the particle A collides with another particle, same mass. Okay. Now thereafter, we need to find condition to complete circular motion. Okay. Now let's do this. 12 part B. Here initial velocity u equal nag root. Then to complete circular motion, so at this position tension must be positive. Then I'll take directly this position. Then mark tension T. Here it's A, take this velocity V. Then E0 level. Vertical circular motion, use conservation of energy and towards center F equals m. Then conservation of energy, half mu square equal mg a 2a plus half m velocity v squared. Now simplify this one. Cancel m. Then u square nhe multiply by 2 4ag plus v square. Then you find v square. Then v square equal n minus 4 ag. Take this one. Then use towards center F equals ma. Towards center F equals ma. Then at the highest point, downward F equals ma. Here forces mg plus t. m v squared over a. Then t equal m v square equal n minus 4 ag. Minus mg. Here simplify, take mg outside. N minus 5. Here it is. Then to complete circular motion, to complete a full circular motion, for full circular motion, t greater than or equal 0. Therefore, mg n minus 5 must be greater than or equal 0. Then n greater than or equal 5. N greater than or equal 5. Okay. Do up to that. So definitely question number 12, part A, system of wedges, and part B, circular motion. In this case, vertical circular motion. Okay. Now next case, when it come to horizontal position, it collides with another particle. Okay. Now let's do this way. So when it come to horizontal position, you take velocity v1. Then by conservation of energy, half mu square equal half m v1 square plus mga. Here potential energy mga, velocity v1 now. Then at this position it has kinetic energy and potential energy. Initially only kinetic energy. Then find v1. NAG v1 square 2ag. Then v1 square equal n minus 2ag. Then v1 n minus 2 ag whole thin root. Here the velocity. So thereafter it collide with another particle. Here same mass m and m. So velocity v1. So thereafter after collision mass 2m, it moving velocity now v2. Moving velocity v2. Then use conservation of momentum mv1 2m v2. mv1 2m v2. Then find v2. v1 over 2. v1 over 2. v1 mean nag, n minus 2 ag root. Divide by 2. Then here after collision velocity. After collision velocity. Then that depends to complete the motion, further motion. Okay, do after that. So thereafter we need to find condition to complete a full circular motion. Then we can do this way. Here at this position, its velocity v2. Then take highest position. Then mass weight 2 mg. Take this velocity v3. Take tension t. Then tension must be positive to complete the circular motion. Now let this E0 level, new E0 level, here height A. Then half into conservation of energy first, of energy, half m v2 square. Here mass now 2m, no? Here half 2m v3 square plus 2m g height simple a. Now simplify. Then v2 square equal v3 square plus 2ag. Then v2 square, we know that one. Here v2 square n minus 2 ag divided by 4. Here v3 square 2ag. Now find v3 square. Find v3 square. Then v3 square equal n minus 10 ag divided by 4. Here 8 minus 2 10 minus 10. Here v3 square. v3 square. Now use downward F equals ma. t plus 2 mg. Now radial acceleration v square divided by r. Then 2m v3 square divided by r mean radius a. Do up to that. Now here the tension. Then to complete full circular motion, then that t must be greater than or equal 0. Then for full circular motion, t greater than or equal 0. Then mg of 4 n minus 14 greater than or equal 0, then n greater than or equal 14. N greater than or equal 14. Complete that. That is question number 12. Okay. Then question number 13, simple harmonic motion. So still we haven't done, I'll skip that. Then question number 14, vector question and coplanar forces question. Let's do that. Question number 14. Position vector of point AB with respect to O are given by vector A and vector B. Here A, OA vector A, OB vector B. Here these are the position vectors. Then the point E is on OA, OE to EA 3 to 4. OE to EA 3 to 4. Here 3 to 4. Here point E 3 to 4. Then D is on OB such that OD to DB 5 to 2. OD to DB 5 to 2. Then here 5 to 2. 5 to 2. G is the intersection point of AD and BE. Here G. We define OG. Then OG vector by the triangle of vector addition. Here we have B separately, no? B vector separately. Therefore, you better to write OG equal OB plus BG. Then OB mean vector B. BG mean lambda times BE. Because BGE on same line, no? Same line. Then vector B, lambda times BE. BE equal minus B plus here 3/4, no? Then 3 over 7 vector A. Vector A. Now you can get the answer. Vector B equal lambda 3 over 7A minus B. Here the relation. Lambda is a constant. Lambda is a constant. Lambda not given directly, but you have to select that. According to the relation, you better to consider OBG triangle. Obtain another expression for OG, find position vector of G in terms of A and B. Then you find another relation for OG. Here OG vector equal OG vector equal OE plus EG. Better get OA plus AG. OA plus AG. Then OA vector A, AG, let mu times AD. AGD same line. Mu AD. AD equal minus A plus 5 over 7 B. 5 over 7 B. Your ratio 5 to 2, then 5 divided by 2, you need divide, then B divide 5 times B over 7. Then here second relation, vector A equal A plus mu 5 over 7 B minus A. Here second relation. Here first relation. Then now they are same, no? Vector B lambda 3 over 7A minus B equal A mu 5 over 7B minus A. Now multiply by 7. 7B 3 lambda A, 7 lambda B. Here 7B, 3 lambda A, 7 lambda B, 7A, 5 mu B, 7 mu A. Get the relation. Now take all terms one side, then 3 lambda plus 7 mu minus 7 A. Then B, here take this side, 7 minus 7 lambda minus 5 mu B equal null. Here 3 lambda plus 7 mu minus 7A. Here 7 and here minus 7 lambda and 5 mu. Okay. Now you separately equal these coefficients to 0 according to the theorem. Therefore, 3 lambda plus 7 mu minus 7 0, then corresponding to that 3 lambda plus 7 mu equals 7, first equation. Then 7 minus 7 lambda minus 5 mu 0. Then 7 lambda plus 5 mu equal 7. Second equation. Then solve simultaneous equation. You find only one unknown. That's enough. Then multiply by 3 here, 7 here, 1 into 7, 2 into 3. Then 7, 3 lambda 7 mu, 3 times 7 lambda 5 mu, and go further. Then here 7 times 7, minus 7 times 3, 49 minus 15 mu, 7 times 4, 49, 39, 34 mu, 7 times 4, mu 14 divided by 17, 14 divided by 17. Divisible by 2 now, then 14, 17. Therefore, OG value, OG vector, here take this relation, A plus mu 14 over 17, 5 over 7B minus A. Okay, simplify now. 17A, 10B, 14A divided by 17. Here 17A, 14 cancel with this, 2 times 5, 10, here 14. Then final answer 3A, 1 over 17, 3A plus 10B. Here OG, vector OG. Okay, complete that. Now 14 part B, coplanar forces section, little special one, coplanar forces part. Now system of forces given with xy coordinates. Here x-axis, y-axis. Here first force capital X1, capital Y1 at simple X1, Y1 point. And here x2, y2 force, x2, y2 point, x2, y2 point. So there's system of forces like that. There are n number of forces, 1 to n, then there are n number of forces. Then let's sketch further. You can sketch another force somewhere here, x3, y3, here x3, y3 point. Then there are n number of forces all over this plane. Okay. Now, when you resolve horizontally, then take capital X, x1 plus, x2 plus, up to xn sum. We denote this one by sigma I equal 1 to n xi. That is horizontal component. Then vertical component, say y, then y1 plus, y2 plus, y3 up to yn sum. Then sigma I equal 1 to n yi, xi, yi. Then let moment about O, here O point, say G, about O moment. Then look carefully, y1 times x1, capital Y1 times simple x1 minus x1 times here simple y1. First couple, here for these two. Then similarly you write for the others forces. Then y2, x2, x2, y2. It goes like that. It goes like that. Up to n number of forces. We have n number of forces. Then here final one will be yn, xn, xn, yn. Don't miss capital N, capital X and capital Y. Then here final one, sigma I equal 1 to n, I equal 1 to n, yi, xi, xi, yi. Here third relation. Here first relation, second relation and third relation. Third relation. Okay, first do up to that. First do up to that. Now here you need to get moment about a given point a comma b, given point a comma b. Okay, we can do this way now. Now here this system equivalent to, here this system equivalent to here x and y, here capital X component, capital Y component, about origin moment g, here g, no? G, and here x and y. Here the system you equate to, here point a comma b, here x, y and m, x, y and m. Okay. When we add a couple, then here this force system will be shifted. Therefore, for this system, moment about O, that is G, equal, here moment about O, capital M plus y times here A minus x times here B. Sorry, මෙතනින් moment එක ගන්න තියෙන. මේක equal කරපු කතාව වැරදි. About a moment. About here this point a moment, m equal g plus x times a minus y times b. Y times a ne. පොඩ්ඩයි මෙතන පොඩ්ඩ හරියට බලමු. Okay, see this relation. Then about a comma b point, take a. I'll write here about a moment. That is m. Then y1 times x1 minus a. x1 times y1 minus b. Here first couple. So about this point moment, y1 times x1 minus a. Then x1 times y1 minus b. Then similar types terms you need to add. y2 times x2 minus b, x2 minus a, x2 times y2 minus b. Then yn times xn minus a, xn times yn minus b. Then m y1 x1 minus x1 y1. Take these two. y2 x2 y2. take these two, yn xn, xn yn, minus a plus x1 times, here take b outside, x1, x2, x3, xn. Take minus a outside, here y1, y2, yn sum. Then for this part say capital G about origin moment. This is the one about origin moment. Therefore m equal here G plus b times here capital X, a times here capital Y. අරකම තමයි එන්නේ. G minus ay plus bx. Sign එක අරකම තමයි එන්නේ. Okay, complete. The correction. Okay, now here moment about 3 point given, moment about 3 points given, minus row 3 comma 1 minus row 3 comma 1 0 comma 2, moment 2 6 2 8 and 6. Show that the system equivalent to single force of inclination 60 and need to find x and y component, x and y intercept of the resultant. Okay, now here the system of forces not given, system of forces not given, but let's do this say there is special type correction. Here x axis, y axis, row 3 comma 1, here row 3 comma 1, here point A, point A, then minus row 3 comma 1, here say point B, Then 0, 2, point B. You take moment about each point. Let's take moment about A. Then before that you mark capital X force and capital Y force like this at simple x, y. Then about A moment, that is given 2. Y times x minus root 3, here coordinate x now. X times y minus 1. First equation. About B moment, say GB. So that is given 8. Y times here x plus root 3. X times here y minus 1. Then about C point, GC, that is given 6. Y times x minus x times y minus 2. Here third relation. Now here system of forces are not given, then you better to mark capital X and Y resultant. Then according to that, write moment. So here general point simple x, y and component capital Xy. We have 3 equations now. Now let's move further. One minus 2, take 2 minus 1, 8 minus 2, 6. Here cancel yx, add 2 root 3y. Here xi cancel. Then we can obtain y value directly. Root 3. Y value root 3. Then further simplify, further subtract 2 minus 3. Then 8 minus 6, 4. 8 minus 6, 2. Yx cancel, root 3y. Yx cancel. Here plus x2 minus x. Here plus x minus x. 2x now. Then put root 3 here. 2 root 3 x. Then x equal 1. Therefore resultant horizontal component 1, vertical component root 3. Then you can find resultant magnitude and direction. Then r equal 1 square plus root 3 square root. We have 2 magnitude, 2 units. Then alpha, tan inverse root 3 divided by 1, then that is 60-degree inclination. 60-degree inclination to the horizontal. 60-degree inclination. We need to show that. Thereafter, we need to find x and y intercept of the resultant. So first do up to that. This is very special type question. The system of forces not given. Therefore, you better to mark that x, y, and using moment relation, we need to get x and y. Okay, then you know x and y values. You can substitute that value for here one equation. I will take here the simple equation 3, then by 3, 6, here capital Y root 3, x1, here line of action of the resultant, Let's simplify. Root 3x minus y plus 2 equal 4. Here line of action, equation of the line of action of the resultant. Equation of the line of action of the resultant then when x0 y value 4 minus 4, we call y-intercept here. When y0 x value 4 over root 3, here we call x-intercept. Likewise, you can find x and y intercepts. Complete. මේ questions හරි rare questions හරිද? ඔයාලා හොඳට practice කරලා තියාගන්න මේ හැම වෙලේම set වෙන්නේ නැහැ මේ වගේ questions. ලොකු දෙයක්ුත් නැහැ. ඒ වගේ special points කීපයක් විතරක් තියෙනවා. ඒ ටික හැම වෙලේම පොඩ්ඩක් memory එකේ තියාගන්න. Question number 15 අපි ළඟදී කරා මේ question එක brain gym paper එක. එහෙනම් මම ඒක discuss කරන්න යන්නේ හැමම ඔය question එකම කරා ළඟදී. Question number 15 එක. Question number 16 එකට ඊළඟට එන්න. Complete this. Okay. Now question number 16, center of gravity question. Hollow cone. Same vertical angle alpha, vertex O, mass per unit area rho. Show that the mass, full mass. Okay, let's do that. Question number 16. We need to find full mass first. Let's do this, say. Here semi-vertical angle alpha, height simple h, then find radius r and slant height simple L, tan alpha r over h, then r equal h tan alpha, cos alpha h over L, then L equal h sec alpha, then mass area pi r L times density, r mean h tan alpha, L mean h sec alpha. Pi h square pi rho h square sec alpha tan alpha. That's how we find the mass. Now, next case, here for this cone, a circular disc is attached. Circular disc is attached. Then height simple h, semi-vertical angle alpha. Then by symmetry, center of gravity lies on the x-axis. Therefore, y bar 0. Then take the table object, mass, center of gravity, here disk, then combined body. Here mass capital M, let's say capital M. Then disk mass, let's say simple M. Then pi r square rho. Area times density. R mean h tan alpha. Then pi h square tan square alpha rho. Then say simple M. Then capital M plus simple M. Center of gravity is, here center of gravity for hollow cone h divided by 3. For this disk, it is 0. Need to find x bar. For disk at the center, hollow cone from the base h divided by 3. Now take moment. Okay, let's simplify. Then moment about y-axis, then capital M plus simple M, x bar equal capital M h over 3 plus simple M times 0. Then x bar equal mh divided by 3 m plus m. Here the center of gravity. Then take h outside, h over 3 outside, capital M, you take this, capital M, take this one. Okay, continue. Capital M, pi rho h square sec alpha tan alpha pi rho h square sec alpha tan alpha plus simple m pi h square tan square alpha rho. Now simplify. Cancel pi rho h squared, pi rho h square, pi h square rho. Then h divided by 3 sec alpha tan alpha sec alpha tan alpha plus tan squared alpha. Here the center of gravity from center. But we need to find center of gravity from O, no? Do up to that. Okay, then that is center of gravity from B, no? From this B. Then center of gravity from O. Center of gravity from O. If O is here, no? Then we got x bar here. Then h minus x bar. H minus x bar. H minus h divided by 3 sec alpha tan alpha. We got this now. Over sec alpha tan alpha plus tan squared alpha. Now better to cancel tan alpha term. Now we have denominator sec alpha plus tan alpha. Now you take h divided by 3 outside. Then 3 sec alpha plus tan alpha minus sec alpha. Sec alpha plus tan alpha. Now h, put 3 inside. Sec alpha, 2/3 sec alpha. Sec alpha plus tan alpha. Coefficient එක මාරු වෙලා ආවිල්ලා තියෙන්නේ බලමු. Okay, මෙතන 3 එන්නේ. Plus 3 tan alpha, now it is okay. 1. Okay, then here it's gonna suspend here B no, here O point A. Here we know x bar. So if it is suspended at A, then here this will be vertical. Assume vertical. Assume vertical. Then here center of gravity and suspending point will be vertical because assume vertical. Now here given if OA and AB make equal angle, OA and AB make equal angle, alpha and alpha. So we need to find sin alpha value. Sin alpha value. We know x bar, we know R, we know H given. Then here R, we know L, here H. Then here tan alpha equal x bar over R. R tan alpha equal x bar. R tan alpha equal x bar. Then x bar, here h divided by 3, sec alpha tan alpha over sec tan, that's the one. You put that on here. And simplify. That is h divided by 3 sec alpha tan alpha divided by sec alpha. You cancel tan alpha term. Sec alpha plus tan alpha. Then you know R value. H tan alpha. Here H tan alpha. Put that one and simplify trigonometric relation. Okay, complete that. පොඩ්ඩක් ඉන්න මෙතන මේ පොඩි මිස් එකක් තියෙනවා. මෙතන මේක ඇල්ෆා කියලා දීලා නැහැ මමනේ දාගත්ත එකනේ. ඒක වෙන ඇන්ගල් එකක් දාගන්න ඕනේ. බීටා හැම එන්න ඕනේ. මේකට මේ sin rule එක ගන්න වෙන්නේ ඒකින්ද. sin rule එක ගන්න තියෙන්නේ මේ triangle එක ගන්න common side and non side. common side non side අරගෙන ඒ දෙන්න divide කරන්න trigonometry වලින් යන්නේ. එහෙම නැත්නම් cot theorem එක apply කරන්නත් පුළුවන් වෙයි. sin rule එක දාන්න එතන හරිය. common side and take non side. මේක ගත්තත් කමන්නේ. දෙන්නම දන්නවනේ. and common side and non side. මේක හරි දෙකම ගත්තත් කමන්නේ. Check this. Here take A over sin 90, sin rule, R over sin 90 minus beta. Here first relation, A cos beta equal R. Then your common side A divided by here this angle alpha, same vertical angle, A over sin alpha equal, then here center of gravity we know that, take here x bar 1. X bar 1 over sin beta. මේක x bar over sin beta ම ගත්තා නම් හොඳයි නේ. x bar over sin beta. a sin beta equal x bar. And here a sin beta x bar 1 sin alpha. Then x bar equal x bar 1 sin alpha. Here x bar 1 and here x bar. Then take those two and put it here. Then we have relation, you can simplify. Then x bar equal h over 3 sec alpha, h over 3 sec alpha plus tan alpha. Here sin alpha, x bar 1 here put x bar 1, here it is h 2/3 sec alpha plus tan alpha over sec alpha plus tan alpha. Now simplify, cancel h, cancel, simplify. Then sec alpha multiply by 3, then 2 sin alpha sec alpha plus 3 sin alpha sec alpha. Then cancel sec alpha. Sin alpha 1 over 5. Sin alpha 1/3 pin antiyani. Kari simplification error එකක් තියෙනවා. Simplification එක check කරලා බලන්න method එක හරි. හරි අපි එන අදට උතන ඉවර කරමු නේද? ඔයාලගේ 17 question එක statistic probability තාම කරේ නැති ඉඳලා discuss කරන්නේ නැහැ. ඉස්සරහට ඒ lesson එක කරාට පස්සේ ඔය papers ඔක්කොගේම ඒ complete discuss කරමු නැති මේ questions ටික අපි කතා කරගෙන යමු. හරි අපි එහෙනම් අදට උතන ඉවර කරමු නේ.